Hi, this is Craig Stocks here for Utah Desert Remote Observatories. You can find us online at utahdesertremote.com, and if you look at the blog section, you'll find a blog post with these videos and some more information and links to downloads. This is part 3 of my two-part series on a better way of working using a layer-based non-destructive workflow in Photoshop. It's fast, easy, flexible, and yields better results. And if you haven't watched the first two parts, I would encourage you to go watch those first. But if you want to just jump in here, I'll give a very quick recap of what we've done so far. The advantages of a layer-based workflow are that it's fast, it supports layer adjustments, which are really the kind of the foundation of a non-destructive workflow using adjustment layers. It makes star extraction simple and powerful, especially when you're using a plug-in like Star Exterminator, which functions as a filter, and you can use it as a smart filter. It also allows easily using the same data in multiple ways, and that's really what we're going to be exploring in this video, particularly with narrowband data. And it makes it easy to add additional data if you return to a target later. For this data, we ran a sequence in Voyager from the remote observatory, and we captured hydrogen, oxygen, and sulfur at 600 seconds each, and red, green, and blue at 120 seconds each. And that was with the Takahashi FSQ-106 on a Paramount MX Plus mount. I took all of the data into Deep Sky Stacker, and I chose one of the hydrogen frames, in fact, the hydrogen frame with the best score, to use as a reference frame, and then processed each one of the 6 groups using that same reference frame so that everything aligns when I get it into Photoshop. And then I saved the narrowband data as 32-bit FITS files. A little bit unusual, but the reason I do that is so that I can then bring those FITS files into a program called FITS Liberator, and it has some really nice stretching algorithms, and the one that I normally use is the inverse hyperbolic sine, or arcsine H, stretching algorithm, and it gives you the ability to adjust both the black points and the white points to get kind of the amount of stretch that you want. And then I save those as 16-bit TIFF files. So when I'm done, I have red, green, and blue unstretched data from Deep Sky Stacker that it has automatically saved into autosave.tiff files, and those are 32-bit TIFFs. And then from FITS Liberator, I have hydrogen, oxygen, and sulfur saved as 16-bit TIFF files. So from those 6 input files, we created this output file, which is an RGB with some hydrogen, oxygen, and sulfur added. So in the first 2 videos, we started with the base image, subtracted the stars, and then did a light stretch, and also subtracted the stars from that, so that we could create a layer that has just the stars in nice, small, colorful stars. We added those nice, small, colorful stars, plus some of the darker detail from the light stretch image to the core, and that created kind of an RGB image. We then went to the narrowband data and first created a hydrogen, oxygen, oxygen HOO image, which looks similar to natural color. We also explored an SHO or Hubble palette version of that. But then we removed the stars from the narrowband data, added RGB stars, and then started combining it with the RGB, kind of the base layer. And to that, we added oxygen to get a little bit more detail around the kind of the collar or the outside of the Orion Nebula. We also added some oxygen and some hydrogen to get a little bit of that hydrogen background glow. Added a little bit of detail from the sulfur data into the brightest part of the core of the Orion Nebula. And after a little bit of processing in Photoshop to kind of fine-tune the balance between the 3 elements, plus the RGB data, I then took that into Lightroom, where I did the final contrast and color adjustments, and more importantly, where I did the final rotate and crop. So what I want to do today is go back to the narrowband data and explore some different ways of color mapping the narrowband data. In particular, we'll look at a variation like an OHS, or oxygen, hydrogen, sulfur, mapped to red, green, and blue, as well as the Hubble SHO, and talk about how from the basic color mapping, what do you do from there. So with that, let's go into Photoshop, and this is where we left off in Photoshop with the RGB image with nice small stars and the oxygen, sulfur, and hydrogen added from narrowband data. And one of the useful things that we have in the layer stack is we have our RGB stars. So I can, as we did before, we can turn those off and on just to see a starless image or to see it with stars. But more importantly, that's also where we would find the stars if we want to use them somewhere else. And again, I haven't cropped the images, so we can pretty freely move things from file to file. So let's go back to our narrowband file, and this was pretty much where we left off, where we had the sulfur, oxygen, and hydrogen as 3-layer groups, and within each one of those groups we have a levels adjustment to tweak the brightness up and down of that individual element, and as well as a starless version and a starred version that we removed the stars from. So the first thing we might want to do is grab the stars over here, and let's just reuse those in the narrowband image. So I'm going to tap V to activate the Move tool. The stars layer group is active, so I will click and drag up to the tab of the file I want to drop these into. Continue holding the mouse button down, drag down into the image area, press and hold the Shift key, and then release the mouse, and then release the Shift key. So now we have our RGB stars added on top of the narrowband data, and we can begin to play with the narrowband data. Right now this is mapped as an SHO, or Hubble palette image. And if we want to play with the color balance of this, we can do it a couple different ways. The obvious way is to go into each one of the groups and go to the levels adjustment within that group, and we can play with the relative brightness and contrast by moving the white and black and midpoints of that individual element if we want to make it more or less prominent in the image. If we want to really bring out the hydrogen, we can do something like that, of bringing up the midpoints and darkening the black point. And we can do the same thing obviously with oxygen and sulfur to really kind of fine-tune how we want this Hubble palette image to look. And Hubble palette maps hydrogen to green, and green is a nice bright image, so it shows up well to our eyesight. It translates as a bright color as opposed to blue that translates as a dark color, and red also translates as a fairly dark color. So it makes those details nice and bright and visible. You may not like the kind of the dominant green color in the image, because we don't normally think of green with Astro images. And most people will wind up adjusting the color in a Hubble palette from the base. They'll kind of move it towards more of a cyan color. And there's a couple different ways you can do that. Generally what I would do is go to the top layer group, and if we want to add adjustment layers on top of our narrowband data but below the stars, it's helpful to have that group closed. The disclosure triangle on the side will open and close that group. In other words, it will reveal what's in the group if we open it, and if it's closed, then we just see the one layer representing that whole group. The important thing about that is if I add an adjustment layer, for instance, let's add a Hue Saturation Adjustment. If the group is closed, when I add the Hue Saturation Adjustment layer, it will add on top of that layer group. So this is really where we want it, between the three narrowband groups and the group that contains the stars. And then any adjustments here would affect the pictures or the layers underneath, but wouldn't affect the star layer. Now, just for comparison, let me delete this just for a moment. If the sulfur group, which is the top layer group, is open, in other words, we've revealed the layers within it, even though I'm highlighting the layer group and not any of the contents within the layer, but if I'm highlighting the layer group, if I add an adjustment layer, notice that it adds inside that group, in this case inside the sulfur group, rather than above the sulfur group, which is really where we want it. It's not a big deal. We can always grab it and move it up to put it where we want it, above the sulfur group and below the star group. But it may be a little bit confusing if you find it inside a group, and then you won't be getting the effect that you were expecting to get. So let's start with it here above the three narrowband layers that we have mapped as sulfur, hydrogen, and oxygen as red, green, and blue. An easy way to kind of twirl the color wheel, if you will, is in a Hue Saturation Adjustment. Just grab the hue slider, and if we move it back and forth, we can kind of rotate that color palette. And if you rotate it a lot of times you'll find that you start losing a lot of detail. But a little bit of rotation, so for instance towards the blue and magenta color, knocks off some of the edge of the green and brings out a little bit more of the blue. So we might see that as an improvement. If I turn that layer off, that was before, this is after. And generally what I'm trying to do is maximize the amount of color contrast between the different elements. We can also target individual colors. So for instance, if I target the yellows and move the slider, that we'll find that there really are some yellows in there that we thought were green, and we can adjust their color as well as the brightness and saturation to make the background a little bit more cyan rather than green. So you might play around with that as an alternative. If we go to the greens, we might want to adjust those as well. And in general, what I'm trying to do is get as much color contrast as I can between the different colors. And this is one way to do it, by using hue saturation. And let me just delete this. Another way of doing it is with the selective color. And when we go to selective color, we have a drop down where we can select what color we want to target. For instance, if we want to target the yellows, and then we can change the amount of red and cyan, green and magenta, or yellow and blue that we want in those colors. Now, if I'm targeting yellow, the yellow slider really affects the saturation of the yellow more so than the color. The green magenta will affect the color, as will the red cyan. So we can go into the different colors and begin to play with, for each color, what do we want the contribution of each element to be, and fine-tune the look of the colors. I like this approach, either this one or the one using hue saturation. The nice part of this is it lets you work on the image visually rather than trying to do numerical adjustments and anticipate what you think those numerical adjustments are going to look like. That you can kind of directly make the adjustments and look at the results and hopefully hone in on the kind of result that you want. So this is playing with the SHO and different ways to approach it. Of course, you can also just add a color balance, and this gives you a nice overall method of adjusting the color balance. And at some point you may want to add a hue saturation and actually play with the saturation either of individual colors or the image overall. So at this point, let's leave the SHO, and I'll just delete these three adjustment layers. And let's try a completely different kind of color mapping. Let's do an OHS, which is fairly popular for Orion. So for OHS, we'll have oxygen mapped as red, and right now we have it mapped as blue. So we'll switch that to red, turn off the blue, and then sulfur will be mapped as blue. Currently it's mapped as red, so we're really just kind of reversing the oxygen and sulfur that we would find in the Hubble palette. We'll map it as blue instead of red. And as before, the hydrogen, we have all three colors, so the hydrogen group is contributing all three, red, green, and blue. The oxygen group now is mapped to red, so it's replacing the red from the hydrogen. Sulfur is mapped as blue, so it's replacing the blue from the hydrogen layer. So that gives us an OHS color palette. And let's just start with a color balance, and we can play with the color balance as a starting point and see if there's a balance that we like better than others. So that's starting to look interesting. Let's add a hue saturation and see if we want to rotate the colors a little bit. Adding more blue to the background seems to make it interesting. So that's really bringing out the blue in the sulfur. And we can even go to the sulfur layer if we want to get a little bit more aggressive with that and bring out a little bit more of that blue in the background. Go back to the hue saturation, and as you can see, this is very much an iterative process that you can go through and go back and forth as you make adjustments. You can also target individual tones in the color balance. The default is that it's targeting mid-tones. If we target shadows, we can play with the color primarily in the shadows. And you may find if you, for instance, are adding color, a dark color like blue or red to the shadows, you may find it's darkening the background rather than just changing the color. To overcome that, we can go to our blending modes and change the blending mode to color. And then that way, as we change the color of the shadows, it'll change the color without having so much effect on the density of the background. And maybe we want to go to highlights and play with some of the color there. And this is in particular is going to be affecting the red oxygen that shows up in the area around the nebula. So you can basically just continue playing with it until you find a combination you like. As you start to move towards something you like, you can kind of continue kind of refining that to move it more and more in the direction you like. You may like this, you may hate this. I'm really not trying to just tell you this is the right color combination to pursue. What I'm really hoping to show you is the tools you can use to try to move towards the color combination and the color mapping that you like best. If we find that we have certain colors that are becoming more saturated than we want and other colors that are not saturated enough, again, we can add another hue saturation, and we can target, for instance, we can target just the yellows. And if I'm not sure what color it is, I can use the color picker. Once I've chosen a specific color, I can pick up the color picker and then click on the area that I want to target, and it will move the color selector band so that it's centered on that color. And then I might want to, maybe reduce the contrast or the saturation, and maybe add, well, if I add brightness, I lose saturation. So it's sometimes, like I say, it can be a very iterative process, and you can also, of course, fine-tune what color you want that color to translate into if we want more red or more green in that. And then we can also go to, for instance, the cyans. And again, we'll take the color picker and we'll pick a particular color. And let's increase the saturation and the brightness of that. And I'll go back to the yellows and maybe dial down the saturation to try to find a balance between saturation and brightness of the cyans and the yellows. And maybe I'll grab another color balance and tweak a little bit more. And I think that's starting to look interesting. I don't know if it's looking good, but it's looking interesting. So I think I'll leave it here. What we've really done is demonstrate how a layer-based non-destructive workflow lets you preserve all of the data that you worked so hard to capture in individual layers and layer groups. And in this case, we have layer groups for hydrogen, oxygen, and sulfur. I can change the way each one of those layer groups is color mapped by just going into the Advanced Blending Options dialog and choosing what color do I want to represent each layer group. So in this case, we have blue representing sulfur. We can add adjustment layers within the groups, which we've done using a levels adjustment layer. And we can also add adjustment layers that affect the nebula overall without affecting the stars, because the stars themselves are in their own layer group on top. So if we opt at the end for a starless version of this, we can just turn off the stars, and there we have a starless OHS version with some adjustments. Or if we like the stars, we can turn those back on. And within the stars group, we can add, I would usually use a levels adjustment. If we need to make any adjustments to the stars themselves, generally if I move the dark slider in, it will make the stars smaller. And if I want the stars to be a little bit more prominent, I can grab the middle slider and move it to the left and increase the presence of the stars. If we want more or less color saturation in the stars themselves, we could simply add a saturation, Hue Saturation layer, and add more saturation to the stars to really bring that out. If we find the color balance is off a little bit, I will sometimes even add a color balance, and sometimes we need to add a little bit of red or yellow to the stars if they're looking a little bit too blue. So that's how I use a layer-based non-destructive workflow. We've gone through broadband iterations of this. We added narrowband data to the broadband, and now we've really spent some time exploring just the narrowband data and some different color mappings. I hope you found this useful. If you have any questions or comments, feel free to drop them below the video, and be sure to visit our website at utahdesertremote.com and go to the blog section for more information about these 3 videos and some additional information in the text. That's it for me today. I hope you have a great day today and an even better tonight under a clear, dark sky, and I will see you later.